Day four, day four, day four. Ready, buddy, day four. Line up, everybody, line up, line up. Well, sorry, everybody. I got bubble guppies on the brain. For anybody who has little siblings, you know bubble guppies. You know the pain that's been the past 2.5 months for me. All right, so anyway, doing day four right now. All right, application problems. Let's just get to it. A town projects that its population, or projects its population to increase by 5% every year. Population is now 10,000. What will the population be in 10 years? Okay, so anytime you see an increase or a decrease by a percentage, immediately you know it's geometric. Percentage is geometric with this, okay? Just multiplying by that percentage. And this, we're finding basically just the population in 10 years. So we're finding the geometric nth term, okay? Now, Mrs. Middleton wrote that R equals 1.05. That's not necessarily the case. Look up here. R is technically 0.05. And I just want to point this out because I'm sure you've done this in Algebra 1 and Algebra 2. You've gone over exponential growth models and exponential decay models. Exponential growth, if you recall, is the initial term A, and then if it's growth, it's 1 plus R. Normally you deal with money like the interest rate. If it's exponential decay, it's 1 minus R. Now, the end product is exactly what Mrs. Middleton wrote. It's correct right there because this is an exponential growth model right here. Okay, so so I'm going to do 1 plus R. So this is technically not R, but 1 plus R right here, and you get 1.05. So Mr. Cody, what if it was exponential decay? Well, then I'd do 1 minus 0.05, and I would get 0.95. You follow? All right, so you take the initial amount, 10,000. That's like the first term, times the 1 plus R, which is 1.05 to the 10th power. All right, and you got your term. And why did Mrs. Middleton write 11? Well, because if you count now as year 0, think about this. Year 0 is now, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why did she say A sub 11? Because if you count all that up, that's 11 terms right there. Yeah, technically I even wrote the wrong thing. Like this should just be to the nth power and this should just be to the nth power. Oops, sorry, I don't know what I just did right there. There we go. I don't know why it's not erasing. There we go. Let me just erase it all and I'll rewrite it. Yeah. Okay, so in 10 years, you're just raising it to the 10th power. Okay, but technically you are finding the 11th term because you're starting at year 0. Okay, so there we go. All right. And if you plug that into your calculator, you get 16,288 people. Watchung will graduate 250 students this year. It is projected that it will graduate 15 more students per year for the next 8 years, including this year. And that's an important thing. This is year 0. So how many years again? 0, 1, 2, 3, 4, 5, 6, 7, 8. How many total years have elapsed? That's 9 total years. So you're finding technically the sum of the first 9 years. And this is an arithmetic sequence. Why is it arithmetic? Because it's just plus 15. You're adding 15 more each time. So what things do you need for the arithmetic sum formula? You need n, that's 9. You need the first term, well, that's 250. But then you need the 9th term. How do you find the 9th term? You go right there. You use the arithmetic nth term formula. The 9th term is just 250 plus 15 times 8, and you get 370. 370, plug it in, right there into that part of the formula, and you get 2,790 students by the end of year. Oh my gosh, all together. Now that's not how many students are graduating that year. That's how many students have graduated overall, the sum over that many years. Okay, a lot of students go through the school. Okay, a house was worth $200,000 7 years ago. Okay, if the prices increased 5%, so once again, exponential growth. So technically this is not R, remember, it's 1 because it's exponential growth, it's 1 plus R, but it's the same thing. What was it worth now? So you could think of it like this. If you count year 0, it's 8 total terms. But if you just think 7 years ago, It was so instead of going from the present to the future, you're going from the past to the present. So in the past, it was 200,000. Then 7 years later, you're now at here in the present. You're increasing 1.05. Okay, that's a plus. Oh my gosh, that was a horrible plus right there. There we go. There's a plus. 1 plus R. $281,420.08. That's how much money you got now. Wow, you gained $81,420.08 just by increasing 5% per year. All right. Or the house, I should say, increased that value. You didn't. Well, I guess you did. You sold it. Hopefully, that's what you get more for it. Okay, the next one, number 4. $100 is available as prize money in a certain contest. Sorry. There will be 4 winners. Each winner gets 1/4 of the amount given to the previous winner. How much does each person receive? Now, this seems like a tricky question. You might say, well, the first person gets $100, and then the next person gets 1/4 of that, which is 25. But wait, no, it's a $100 purse. So in other words, that's how much money is available to give out to all 4 people. So 1/4 is definitely geometric because you're dividing by 4 or multiplying by 1/4 each time. And we're going to use the sum formula here. And the interesting thing is that we know what the sum of 4 terms is. It's $100. All 4 prize amounts have to add up to 100. So what we don't know, or what we also know is that, so we know that the sum, the first 4 terms, is 100. We also know that R is 1/4. So we have every piece of information we need right here. I guess that means that N equals 4. What we don't know is how much the first person is getting. So look at what Mrs. Middleton did. She wrote 100 in this S sub N spot, or S sub 4 spot. Left A sub 1 blank because we don't know it. Or left it as the variable. And then 1 minus R, which is 1/4, raised to the 4th power, divided by 1 minus 1/4. She calculated this, then she divided this into 100 and got A sub 1 equals $75.29. Then after you find A sub 1, the rest is gravy. I mean, then you could literally just divide by 4, get $18.82, divide by 4, get $4.71, divide by 4, and get $1.18. But the trick about this particular word problem was that they were giving you the sum of the 4 terms or the 4 winners, and you needed to find the first term, and from there you could find the next 3 terms. Interesting question right there. If you were given a choice between the following birthday presents, which would you choose, and by what amount would your choice exceed the other option? So choice A, get $100,000, bam, smack right on your birthday. I'll take that. And then $50,000 per day for the next 30 days. So the $100,000, that's not a pattern. That's just a lump sum start. And then you get $50,000 for 30 days, times 30. Okay, so great. That's pretty cool. Or a penny on the first day, 2 cents on the second day, 4 cents on the third day, and so on and so on and so forth. Okay, all the way up to day 30. So let's start out with option A. So in reality, we are going to be doing $100,000 plus the sum of 30 days. Would you agree? All right, the sum of $50,000 per day times 30 days. So let's find out this piece right here. This piece is equal to that right there. So 30 divided by 2, you're getting $50,000 on day 1. You're getting $50,000 on day 30. So basically, that's 15 times $100,000. Well, you know what? I mean, yes, you could have done just $50,000 times 30. Yes, you could have just done that. By the way, that's $1,500,000. $50,000 for 30 days plus the $100,000. You're making a cool $1,600,000 from option A. Not bad, not bad for a month's present. The geometric says, hey, you're doing 0.01 on the first day, 0.02, 2 cents on the second day, 4 cents on the third day, and so on and so forth. I guess the next day would be what, 0.8, 16 cents. So what is R? R could be found by taking any term divided by the previous term. So R equals 2. So we got that going for us. We also know that A sub 1 equals 1 penny. We also know that N equals 30. Do we have all the pieces we need to find the geometric sum? Of course we do. Okay, we got the first term, which is 1 penny. We got R, which is 2, raised to the 30th power. And we get, holy moly guacamole, $10,737,418.23. And so option B is definitely the one to choose. Mrs. Middleton didn't even follow her own directions to the T. She said, by what amount would your choice exceed the other option? So the last thing you'd have to do is just take this 10,700,000 minus 1,600,000 and you'd get the difference. But hopefully you understand the difference between these two. This is a lump sum plus an arithmetic, a lump number plus an arithmetic sum, and this is just a straight up geometric sum. All right, I'm only going to do one more example. These are extra practice problems. You could look at them all. I'm only going through the first problem for a reason. A new car is purchased this year for $24,000. This car depreciates. And if you don't know what the word depreciate means, it means it goes down in value at the rate of 10% per year. So that means R technically is 0.10. All right, what is the value of the car in 6 years? So this is an exponential decay model. An exponential decay model, okay, is the initial term and then 1 minus R, not 1 plus R. You're decaying because you're depreciating. So then 1 minus R is 1 minus 0.1, which is 0.9, which is 1 minus R. And it says it's technically 7 total terms because remember, you're starting at year 0. But if you use just the exponential decay model, you take the 24 grand times 0.9 raised to the 6th power because it's in 6 years. And in 6 years, your $24,000 car is only worth $12,754.58. I just learned this very much firsthand. I traded in my vehicle this week and got a new vehicle or a newly used vehicle. And my trade-in value of my vehicle was so much less than it was before, or when I bought it. All right, everybody, that's it. Got questions, ask.